All right, we're going to go ahead and get started, everyone. Thanks for coming tonight. So I'm Nate Subra. Hi, nice to meet you all. There's 4 of us here. I'm playing frontman today a little bit. So tonight we're going to talk about the KernelCon CTF that we went to a couple months ago. I don't know. I lost track. So we managed to get first place and win the KernelCon black badges. So it's pretty cool. SecDSM represent. So we were Team Loot if you were at KernelCon or playing CTF, so that was us. The name was totally planned, and several of us were up there as volunteering with a tool. So we were just like, hey, we're going to take the name and turn it backwards. So, all right, so we'll go ahead and get started. I'll throw the deck out there. So Nate Subra, we have Ramsey Bennett, we have Trevor Kems, and Tim Lansing. So everyone, vital members of the CTF team. We couldn't have done it without a single person, so we had a lot of fun doing it. So KernelCon, just wanted to rep them real quick. What is it? So they're a security conference out in Omaha, Nebraska, so really close, within 2 hours. This is one of the best conferences you can probably get to from Des Moines. So highly recommend checking them out. They actually sold out this year, like completely. They weren't able to sell any more tickets to hit capacity for like the venue, which is a big ass hotel too, so pretty impressive. So make sure you get on that early. A lot of activities. There are 26 talks there over 2 days, so kind of similar to like most cons, right? Just running a couple days. They had an escape room this year, pretty badass, right? So, and a CTF, which we won, cool. So hardware village, radio hacking village. There were soldering irons out there, fires, all kinds of cool stuff. So nobody got arrested. That's good. So definitely hit them up, check them out. If you're interested, they also do sponsorship too as well. Awesome conference, hands-on recommend them. So just want to throw some pictures out there, like really cool stuff. The swag was amazing. All right, so, all right. So, CTF overview. So there's 42 questions across 6 categories, right? So the number of questions varied per category, but badge, crypto, forensic, miscellaneous, reversing, and web. So it was all AI themed, which really meant mostly Terminator references. So your pop quiz knowledge and everything was really important. So yeah, Skynet. I forgot to take a screenshot of the question board. So here's kind of what it looked like, and then the final scoring. So right now, the score spread looks like it was a lot. It was up until the last second we didn't get like a couple of challenges. I think we were like a half hour before we got our last 2 and kind of sealed it. So it was neck and neck the whole time, is I guess what I'm trying to say. So really great competition this year. The teams were capped at 4. So yeah, 4. So that was a pretty interesting and good balance for a lot of the teams. But yeah, big shout out to the people that we competed with. If you were on one of the teams, awesome job. So kept us running the whole time. All right, so we're just going to go ahead and get right to the recap, right? So I spent a long time on these pictures, man, AI generated. So yeah, we'll just go ahead and get started. So I will go first. First off, I'll post this in Discord. I don't have it up right now, but this is the whole write-up, everything that we solved that we remembered to write down and take screenshots of is on GitHub, and I'll shoot the link out in Discord, so if anyone wants to play at these, all the binaries that we could grab, so if you see a challenge and you're like, I want to mess with that, they're all on GitHub too. So you can go out there and like play with it and screw around. There's several that were unsolved or that we didn't solve. So if you figure them out and like DM me on Discord, I'll buy you a drink some night. So just saying. Anyways, so we'll go ahead and get started. Yeah, we're only going to have time to cover like 1 or 2 per person, so we're just kind of going to go through this. But again, the whole write-up's out there so you guys can dig in if you want. So to start with, 2 of my favorites that we came up were, there's one called Pay to Win. Let me blow this up real quick. So, all right, so, and actually, you know what? Yeah, I prayed to the demo gods. Do it live. All right, so, not time travel. So 2 of the challenges, so there are actually 3 that dealt with in this realm, essentially. But basically the challenge, they gave you a binary and you had to get a flag out of it, right? So you're in the forensics category, so not traditionally reversing, and there was a lot of defenses that were kind of put in place to kind of prevent reversing a little bit. But also the goal is to kind of interact with the environment in like a forensics way. So like you had to figure out how to trick your OS into like telling this binary what it wanted to see. So that doesn't sound too hard, but we'll get into that. So I'll start with pay to win. So pay to win, this small binary that was written, you'll see here, it calculates how much RAM's on the machine, and then it tells us that we don't have a terabyte of RAM. So we spent way too much time just trying to decide which cloud provider we were going to pay, because we were going to pay to win. But it turns out that there's quotas for those, and it took me like 2 weeks to actually get stuff back from Microsoft. But I can now spin up a VM with 2 terabytes of RAM. So if anyone needs it, I've got it, all right? So here's the thing, is that, like, there's a lot of different ways to trick things on Linux. So first off, we tried doing like LD preload, right? We tried screwing around with proc namespaces and trying edited things. Doesn't work. So you see here, it's a statically linked, so that eliminates your LD preload. And then it's stripped to as well, so it made it a little bit tricky to play with as far as reverse engineering. So anyways, we tried those things, no go, right? So, whoops. So one of the things you notice when playing around with it, trace, if you guys aren't familiar, system trace in Linux, it's a good way to just see. It's like procmon for Linux. You should know it if you use Linux at all. So we can go through and we see here, so the information is actually coming from an API call to the kernel, so sysinfo. So is where it's getting that information from. So we didn't have a way to intercept it, right? So it turns out there's this really cool thing called ptrace. So what that looks like, oops, wrong one. So which basically lets you, out of the box on Linux, intercept system calls and like do whatever you want with them. So after a lot of work and trying to figure out how to get this thing to print, so we figured out how to get to the point where we could read the registers and intercept the system call. So print them out. It's actually not the raw memory values in memory. It's the value. It's a pointer to the values. So that was fun for a while too. So, but what that looks like is, so we downloaded more RAM. So basically, you can use ptrace as a way to intercept pretty much any Linux system call and lie to it, and you can actually had a beta of this while we're working on it that paused it and let you interact with it. So pretty cool stuff. So if you want to screw around with Linux, one of the reasons we focused on this was because there was actually another challenge that was very similar. Go down a little bit. Yeah, so what up? So there's actually 2 challenges that we ended up beating using this ptrace method. So we were like, yeah, we got to get this one. So the other one was what up? So same thing. It was a 64-bit binary, statically linked, stripped. It wanted us to have 10 years of uptime. Probably got a box at home that could do it. But same thing. So we were able to use that same ptrace functionality to multiply the uptime and, again, get the flag out. So a couple different ways you can go around it. What are we looking at time-wise? All right, so I've been talking for a couple of minutes, so I'm going to hand it over to, who wants to go? All right.
Hey, everyone. So, I mean, as Nate explained, there's like a number of challenges that, we use ptrace, things like that, to kind of go through and, make things happen differently. I'm just going to kind of point out one that really didn't, I mean, it took a little bit to kind of go through. It was called what processor. And what we had with this one is, just like anything else, you get this executable. Well, this is a Windows executable, so I had to go spin up a Windows VM to go give it a try. And when you ran this executable, what it came back with was, hey, the processor name, did not contain Skynet. And, maybe there's some way to sit there and go about it in ptrace, but there's other ways to solve some of these challenges. So I'm like, well, let's go look for something a little different. And I performed some Google searches. And being that these are within a virtual machine, some of the results I found in the blogs indicated that, I mean, you can go edit the VMX file to actually sit there and kind of like rename what that processor should be. So I did provide like a link to at least one blog post that kind of explains how to do this. And simply just by going with the VMX, I had to add in cpuid.brandstring equals Skynet. And beyond that, just sit there, reboot the VM, and run that process again. Just something like that was simple enough that it would come back and say, hey, yep, perfectly fine. It would spit back that flag. So.
You do the coin one or the crypto one?
What was it?
You want to do the crypto one?
I could do the crypto one as well. Let's go up. Okay, another one I worked on was CornCon. So basically what it started out with was a single string where everything was corn or corn with a 0 instead of an O. Well, just looking off the bat, I mean, of course, this kind of reminds me of binary, 1, 0. It's one way of saying corn or the other. So seeing one was 0, initially, my first thought is I'm like, okay, let's make those all zeros. Let's make the regular corn all ones. So I would use a tool called CyberChef, very good for encoding, decoding. It'll do some decryption capabilities as well as many other things if you haven't used it. But when I sat there and took it to ones and zeros, did that replacement, and then I'm going to sit there and go from binary to actually see, well, what does this look like if I sit there and convert that to something that'd be a little bit more readable. I got anything but readable. I'm not sure that kind of helps see it. But it's just a little bit of gibberish. It almost looks like compiled code maybe a little bit, but definitely nothing that I could kind of do anything else with. So I'm like, well, maybe they did something a little bit tricky, like, hey, maybe the 0 corns were actually 1, the other ones were 0. So I did an XOR just to kind of swap that quickly. So XOR just kind of flipped all the 1s to a 0 and the 0s to a 1 is what I was doing with that. And once I did that, then I ended up with some code that looked like this, and with that equal sign, the N for padding, I thought, okay, well, this is probably base 64, so then I moved on to decode it from base 64. Whoops. Once I did it from base 64, I noticed, hey, it's all numbers, A through F. I'm like, maybe this is, going to be from hex. I did a decode from hex, and then sure enough, I got the flag right there, kernel.
Cool. Yep. Hey, let me, sorry, I should have done this for you. No, sorry, spoiler. Oh, I just want to point out, so. Nice. Trevor makes a land cape, so, all right. Yep. You can zoom it out, I'm sorry.
Yeah, that's
excessive.
My eyes aren't that bad yet. Oh, that's right, you have this awful scrolling.
Yes. Natural.
All right, we'll start with this one first. I'm the one that he was shaming because I didn't take pictures.
Boo.
Sorry, not sorry. So one of the challenges was this horse race bonus, which essentially they had a series of horse races that they would simulate. I believe it was 50, and each race had 6 horses in it, and you had to pick 3 from each race. And if you could pick 2 of the top horses out of your 3, it would be considered a win, and you had to win 70% of the races. Now this heavily implied that you would use AI, but I like Python and not AI.
If you can go to the code repo.
Oh, is it?
Or it's in there, yeah.
Okay. And so what I did was I wrote a script. Do you have it in here? I don't see it.
I don't know. I might have inlined it.
That's fair. I didn't. No, it's not in there.
Okay, never mind. Sorry.
You didn't put it in there?
You were supposed to send it to me.
No, I did send it to you. Anyway, so there were some attributes that you could easily see for the horses that would get you to at least 70%. Well, I'll back that up. As with any good lazy person, what I did was I just set it to try and brute force guesses for a while I went and did other stuff. And it was harder than that, so I'll give it credit. So instead, what I went back and did was I looked at a couple of the attributes of the horses to see which ones typically won. They also gave you a 40,000 race corpus to build from so that you could try and train a data model. But once again, I don't like AI. I like Python. So what I did was I noticed that I believe it was the speed attribute of all the horses were typically indicative of them winning. So I wrote a very weak algorithm essentially in my Python script that weighted that very heavily, and that got me up to where I could hit 60% about once every, 10 minutes or so. But they had this additional challenge, which I begrudgingly didn't get, which required you to get more than, actually no, this was the 70. The original one was 60. I don't see it on here. Maybe that's why it's not in here.
Oh, probably.
Did you drop it? Oh, here it is. Yeah. So this is the actual one. It was a 500 point one, 60%. But I saw this one, which was tempting, so I tried to push it further and find a couple other attributes. A couple of the other anomalies that I noticed were, so each horse was generated by a different language model. They had 4 language models, I believe. It was 3 or 4, and specifically language model 2's horse would almost never win, so I filtered those out and then put some weighting on. They had another attribute called mood or something like that. And once I put in weightings for those, I was able to actually hit 80% a couple times, but they wouldn't accept it. But it's fun. It's fun.
We didn't beat it with AI.
I didn't beat it with AI, so it didn't count.
Take this guy to the casino with you.
Don't do that. Where's the Washington? Yeah, okay. This is one. Once again, I don't really have any images for this, but this one was another one that I found pretty amusing. So this kids have it. The kids these days have it so easy. So the challenge of this one was that you were supposed to have their language model generate an essay, a 100-word essay about George Washington, but they were also going to run the output of that against this other project called Zero GPT, which essentially tries to assess paragraphs or text to see if it was generated by AI. And so you had to trick it into thinking that AI didn't write it, even though it blatantly did. So one of the things that I noticed off the bat was just simply putting the words George Washington in there, got it to pass the About George Washington check, so that was nice. And I tried several ways. I know some people tried similar ways and got it to work. I tried things like write it in the style of a D average 9th grader, and it was like, nope, that's still too high of a percentage. And so I ended up doing a little bit of research on how Zero GPT works, and essentially what it does is it bases things off of perplexity scores. And if you're not familiar with what a perplexity score is, essentially it tries to, the way that LLM typically work is they're just guessing, or they're using the most common frequency of the next word to give you their sentence. And so what Zero GPT does is it essentially takes the inverse of that and says, how would I guess this word next? And if the answer is no, then the perplexity score will go up, which means it's more likely to be by a person. So the way around this was I essentially asked it, hey, write me a 100-word essay about George Washington, and then randomize the order of the words. And that was enough, because random apparently is pretty perplexing.
So the reason why I'm wearing my badge is because it was a little bit special. There's a couple challenges in here. So first off, we didn't do this challenge until like the very last part of it, and apparently we use DALL-E for this, or DALL-E or whatever to generate these, or what else? Yeah. So we have a couple images of me making a LAN cable because I didn't take a picture of it, me doing it. So yeah, there's me apparently.
But like normally AI doesn't do the words, right? If you tell it it's a children's book, it does really good. Just another pro tip.
That's weird. If anybody didn't hear that, apparently if you do a children's book, it does a really good job. This one I thought was kind of creepy. I don't know why, but I don't know. It just pretty much the challenge was, it was like 50 points. You just go make a RJ45 LAN cable and punch it down. I mean, it took me a little bit, but I didn't get the record. But I came out with a teeny tiny little cable to put on my badge. It was barely long enough because I didn't cut off the ends. But oh yeah, so the badge. I don't know if everybody can see this, but it's let me get it on camera. It's essentially a wrench, and what it is a cable tester. So you could test your freshly made cable, and it blinks through all the combos, and if you got like a crisscross wire, it won't work. So that was kind of neat, and that's why it's flashing. We'll get to why I have a janky resistor combo up here at the top in a second. But moving on. So another badge thing, I'm going to do these really quickly because some of these are interesting. Back of the badge had a what's called a pigpen cipher. It's on Wikipedia. Did it by hand. Took me a little bit. I think this was the first one we solved. It was like super easy right away. Not too super difficult. We also got we got a couple good badge ones. Blinky Blink was you went up and hooked your badge into a thing at the CTF station, and then you took a video of it. We went up there. And we found an app called Morse Code. Yeah, it's the second one. Morse Code Decoder Engineer. Sorry.
We had to record it twice because if you've been in a CTF, like trying to hold a frickin' phone steady?
Yeah.
Like, no, it's fine.
I was gonna say, yeah, we had to try it a few times because it was just super janky with like our hands that were shaking. However, at the end, yeah, that too. We were just able to use this app. It was really nice. It was just on our phones. We had one phone like held up to it, and we were trying to do that a few times. And it just wasn't working, but we eventually got it. And in the end, we were able to decode the flag after we had decoded it like 2 or 3 times. Then we just kind of combined them all together. So that was kind of fun. And we didn't quite get the crisscross one, did we? Or, yeah, we did. Yeah. Crisscross we got, and this is just a crossover cable. I'll skip that one. But then we did get the Blinky. We did not get Blinky Blink 2 because it was like 4 minutes long. There was a couple ways you could have done it, but we just didn't do it for time reasons. So the really interesting one was this jankiness at the top of my badge. It was called Goldilocks, and essentially the badges have a 555 timer on them that are hard-coded to a certain frequency. Well, the challenge was to get your badge in a certain frequency that they didn't tell you to then go up to the CTF station, and it'll like hook it up, check your frequency, and then output the flag in a little LCD screen they had up there. Well, I tried like 2 or 3 times, and we're in like the last half hour of the competition. I said, screw it, I'm going to go solder a bunch of resistors on here. And I was like, oh no, this is too slow, because I had 3 mega ohm resistors in series. So I just took some solder wire, wrapped it around, and cut out one of the resistors, and was sitting up there massaging the solder wire to make sure it stayed connected. And sure enough, after me sitting up there for like a minute, it just output the flag, and I got a picture of it. So definitely did not intend people to do that for the competition. And this picture actually, or a similar picture, ended up in the end slides of the conference. So, because the person that made the badge was like, no idea you could do this. Like, this is just insane. But that's how I think, right? Think outside the box. And then I did want to touch real quick. I know we're coming down on time. Reverse engineering. Oh yeah, the VoIP one. Let's do that one real quick. This one's more interesting. They essentially give you a PCAP file, and when you open it in Wireshark, you can essentially decode the VoIP data directly in Wireshark, and it'll give you a spectrogram that you can actually play. And it was a Terminator saying like, "Hello, you've called Cyberdyne Industries, I think, and please hold." And yeah, lots of Skynet Terminator references. But on the right-hand part of this image, you can see there's a little, it looks like a data stream, and sure enough, if you use a decoder called mini modem, it actually decodes it at like 300 baud or whatever, and you can see that there's text in there. So once we found that, there was a encrypted code in hex, and this is where, again, you're not supposed to really do this, but went to CyberChef and put that in there, and you have XOR with the phone number. So they say, hey, phone number in a 4-digit code. Well, they didn't give you the 4-digit code. So I said, well, I know the flag format. It's MD5, so we're only going to do hex characters in the middle. Starts with a curly brace, ends with a curly brace. What are you going to do? Brute force all of the last 4 digits of it. Well, the first one ended up being 9 because that made the first curly brace appear. And then the last one was 5 because that made the end curly brace. Now we only got 100 tries to do. So I just sat there spamming, kind of just trying them. And sure enough, I got a valid MD5 string. And the first one I tried that was valid, yep, that's the flag. So I'm like, great. So that was kind of fun, but at the end of the day, definitely not how you're supposed to solve it. But And then quickly for reversing, because that was actually pretty interesting. Long story short, a lot of these were just Ghidra. Throw it in Ghidra, check the strings, and you're done. I think it's down here. Yeah. So this one, 50 points. Just there was a flag in there in the strings that starts with kernel, not kernel R. This one, just you did it in Java decompiler instead. But then this one's Ghidra, but it was we didn't solve it, but another team. I don't know if Logan's here. His team solved it essentially in Ghidra. I just didn't have time to look at it, right? And then there's a bunch of other ones in here that are just Ghidra. But please go check out the GitHub page. This is really cool if you're interested in this. I'll pass it over back to Nate.
All right, so I just want to give a quick shout out. So thanks everyone for coming tonight and listening to us talk about winning. Big thanks to KernelCon for putting on the conference. It was awesome, so highly recommend it. Like I said, get on it early. They sold out this last year. That's the first time they've ever done that, so get your tickets early. Thanks to Tool for having a couple of us out there. We were volunteering, but big thanks to Arden for letting us nerd out on the CTF while we probably should have been out teaching people to lockpick but we got the job done. We were at that sometimes. So thanks, Arden. Our CTF competitors, again, like this was neck and neck the whole time. I don't think we were actually in the lead until like midnight the second day, or like midnight, yeah, at the CTF. So it was a lot of fun, and it was crazy. The score was like neck and neck until the end. We didn't know until like the last hour. So great competition. Thanks for SecDSM for everything they do and for having us out tonight. And thanks you all for coming. So thanks. I'll send the repo out on GitHub. It's just Nate Subra. If you go look at my repos, if you want to take a look. And like I said, all the binaries and stuff out there, feel free to hit any of us up on Discord. If you have any questions or like, you should have done it this way. We probably know, but thanks. We'll take that advice. So.
Oh, yeah.
What's up? Oh. So, like with tradition, so SecDSM has gone out. We go to a lot of cons all around the nation, right? So this is yet another black badge. I don't know how many there are. Brandon probably know. But so, yeah, this is one of the, theirs are actually gold. So I don't know if you can see, but same badge that they handed out. So, but here's the black badge. So thanks, everybody. Have a good night. Nice. Perfect timing.